Okay, asymptotes of a hyperbola. No, not that kind of. Well, you get the idea. And you can see here, we got a little hyperbola right there on his nose. So anyway, that's why I kind of put this picture there. I thought that helped people remember that. So here's what we're going to do for this here. First off, let's take this particular graph. This one has this would be a horizontal transverse. And the first thing they're going to do is they have what they call a conjugate axis, which is vertical to the transverse axis, which this particular transverse axis is horizontal. That's the conjugate axis. And the conjugate axis is the length of 2b. Whatever b is, you double it. You go kind of b direction each side from the center. And you also have your dots there at your vertex. And basically, you make a square. And then what we do with the square is we cut it diagonally along the to the points right there, and that makes our transverse axis. Our diagonal axis. And what happens here is this: these are like our asymptotes that it can't touch this. It won't touch those particular deals right there, but it will get close to it. So here's what happens: is they going out there, and here's our formula for it. Those are our asymptotes, diagonal asymptotes. If it's a horizontal one, we have the y equals your k value, whatever the center is, plus or minus, because you guess you're going to have one slope. If this slope is like, say, going up 3/2, then the other one's got to go down 3/2. That makes sense. But anyway, that's what this is referring to right here, minus your center. See your center here, inside liar, right there, your vertical. And it says if it's this one here, you have the b value over the a value for your horizontal transverse. And if it was turned sideways there, if I was to take the camera and turn it, your vertical transverse axis would be then the following. The a is on top. So on the horizontal, b is on top. On the vertical transverse, the a is on top.